And I think I should be live. I'm about a minute early. So if anyone is already on here as I'm loading things up, as always, it's great if you want to let me know in the chat that you can hear me. I think only one time I had my audio messed up, but I always like to double check. Also, if you're already watching, if you want to say hello in the chat and maybe put where you're watching from. It's always kind of fun to see where the audience is as well. I am streaming from Seattle. If you've been to Seattle, you can let me know. And again, I'm a little bit early on stream, so we're going to get going here in a few minutes. We're going to be waiting for more people to join in. But as you join in, again, let me know in the chat, maybe where you're watching from. If you have any large language model applications you're working on and you want to share what you're working on, that's also really interesting to hear from everyone as well. Or if you've had any interesting either security issues or performance issues with LLMs in production and you're willing to share that, that would be really fun to hear as well, because that's what we will be talking about today. Specifically, we're going to kind of talk about the OWASP, which stands for, I always forget the acronym, Open Worldwide Application Security Project, I think. I always want to say web instead of worldwide, but I'm pretty sure it's worldwide. And they are a common kind of organization that people reference for their like security reports and stuff. Another one you might have heard of is NIST. I forget what that stands for. I think that's National Institute Security Technology, maybe. I know they also fairly recently came out with their LLM security report as well. And that'd be fun to maybe do another talk or workshop on them. I don't remember how they compare. I know I looked briefly at it, but today we'll be talking about the OWASP top 10 for LLMs. And I see quite a few people just joined in. We're going to get going here in a minute, but as people are joining, please feel free to introduce yourself in the chat and maybe put where you're watching from. Let me get my screen sharing here. Again, we'll actually get going here in a minute. Also, while people are joining in, I'm going to share a few links. We'll be going through some slides talking about the top 10 LM security things that OWASP has talked about. And then we'll also be going through and I'll show how you can use our open source project LangKit, as well as our AI observability store, YLabs, to kind of monitor and mitigate these security issues. So I'm going to share some links in the chat. One, if you want to follow along when it gets to the hands-on coding part, you can sign up for the free YLabs account. There's no card or anything required. You should just have to verify your email and you should be good to go. I'll share the GitHub link to our open source project called LangKit. We're going to use that again on the hands-on part to extract metrics from language models. So we're going to look at prompts and responses, get some metrics from it, and we can actually use that in our kind of security setup here that we're going to be looking at today, as well as monitoring and evaluating our LLMs, which you'll see a little bit in action today, or I'll point it out. We're going to be focusing probably a little bit more on some of the metrics that you could use for security, but we'll be looking kind of at everything on the hands-on part. And then there's going to be a Colab notebook, which is going to have the code where we're going to run today. Again, we'll be doing slides and then hands-on part. So you're also welcome to just watch, but I definitely encourage you to follow along and create the free YLabs account and then follow along with the code part if you're interested about actually like implementing things in your pipeline or application. I see Rahul said, "Hello, Sage. It's great to see you again. And excited to learn from you today." Awesome. Welcome back, Rahul. I know you're a regular. Always great to have you here. And always happy when someone says hello in the chat. It definitely makes it more fun for me presenting. So thank you. And I'm going to share these links one more time in the LinkedIn stream, and then we'll get going through the slides. So we're streaming on YouTube and LinkedIn. Also, if you're coming back and watching this as a recording on YouTube, all these links will also be in the description below. And the recording is going to be at the same link that you're watching at right now. And then on LinkedIn, go to the comments, and all the links will be in the comments as well. So if you want to come back to this later, follow along, all those resources will be there for you, either in the comments or in the description on LinkedIn. All right, let's go in slideshow mode. So this is intro to LLM security. We're going to be talking about some of the top security issues from some of the best industry reports. Someone said they're watching from New York City. Oh, awesome. I'm actually visiting New York City next week for the first time. Somehow I haven't made it up there before. So unrelated to our talk today, if you have any recommendations for me, feel free to send those my way in the chat or connect with me on LinkedIn. I always love hearing about the places people recommend, and I'm excited to go visit there for the first time. A quick introduction about myself. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at YLabs. At YLabs, we build tools around AI and ML observability and data observability. So you can implement our open source projects and our platform in various ways in your data pipeline or MLOps pipeline. And for over the last decade, I've worked in software with a lot of ML, previously a lot of computer vision, and I've also done a lot of hardware, mostly with startups in Seattle, but also some in Central Florida. And in general, I love making things with technology. And I'm going to share my LinkedIn in the chat. Feel free to connect with me there and ask questions later. Or you can ask questions in the Slack channel, which is a link I shared in the chat, but also it's in the description below. So if you want to join the Slack and introduce yourself there and meet other people, hopefully that'll be a good place for you to do so. About you. So actually, this is perfect timing because I see like double the amount of people just joined in. And so say hello in the chat. If you want to put where you're watching from, that's always great. And if you want to share a little bit about what you're building with large language models, that would also be great. And then what type of models, would you like to see a workshop next if you really want to share more? And then again, here's the Slack channel. So if you want to stay connected, this will be a good place to do so. Introduce yourself in the channel there. And if you have questions about anything we're going to talk about after the workshop, that's a good place to ask them. I won't see questions in there during the workshop. I'll just see them in the chat, either on LinkedIn or YouTube. So if you have a question during the workshop, please feel free to ask it, but keep it in the live chat here. And again, set up for the people who just joined. Probably the only thing you'll really need to do right now. I need to fix. I don't know why I can't click this right now, but I shared the link previously in the chat, and it's in the description below. The only thing you really need to probably do that you might not already have is set up a YLabs account. Again, you just have to verify your email. There's no card required. And I'm guessing most people already have a Google account because we're going to be using Google Colab on the hands-on portion if you want to follow along again to run our code today. All right, so we're going to talk a little bit about LLM security today. And okay, I did get it right. The Open Worldwide Application Security Project, or otherwise known as OWASP. Most people I always talk to, they always just call it OWASP. And that's why I was like, I actually think that's what the acronym stands for, but I wasn't sure because I forgot. So it's an online community that produces freely available articles and methodologies and documentation tools, a lot around web security. So if you talk with people building applications and they want to make sure they're secure, it's a pretty common organization that is referenced by people when they're trying to hone in security. And specifically today, we're going to be talking about large language model security, which I think is going to be a growing field for quite some time. If you're like a security engineer or working in that space or working with LLMs, I think security is going to be a big topic that's going to keep evolving over time. They just came out with, I forget the date of this, but their report for top 10 security issues that you should keep in mind for large language models. And like I mentioned at the beginning, there's also another organization that just came out with one not too long ago as well. Like they've been working on it and publishing stuff around it. And then I think they came out with official recommendations. That the other one is NIST that people often reference. So this keeps coming up in conversations, and we're going to dive into what those top 10 things are and potentially some ways that you can help mitigate these risks, and how monitoring with YLabs, the company I work for, can potentially help with that, or monitoring in general. We'll see some hands-on stuff with YLabs a little bit later after the slides. Someone said they're working on visual reasoning with large language models. That sounds interesting. I assume tying in computer vision with that and reasoning based on what's in that image. I've seen some really cool applications around that recently. And I shared the link to this in the comments for their official report, so you should definitely go look at their official one. You can download, I think, a whole PDF report. And also, you might want to keep up to date on it. This is like version 1 or something like that. And I'm sure this is going to evolve over time as more and more LLMs get adopted and more people kind of understand how to make them more secure. These recommendations will probably change over time. And if you have any recommendations or things that you've seen in the field, also feel free to share them in the chat. It's always interesting to see kind of what other issues, even if it's not quite security related, people have run into putting large language models in production. Here's a little graph. Also, if you want to check out, so we have a landing page here I'll share in the chat as well, that kind of talks about this stuff. If you want to save that link for reference in the future, you can go visit that and kind of revisit some of the stuff we'll be talking about here, but in a web page format. So the first one is prompt injections. You probably have seen some stuff about this if you've been paying attention with large language models. Often this is kind of also, talked about as jailbreaking. So you're injecting vulnerabilities into large language models. Often you're trying to manipulate the large language model to do something that it wasn't really supposed to do. And the impact ranges, a lot, depending on the large language model, depending on the data it was trained on, depending on what the people are trying to do with it. For example, you may have seen like people trying to get OpenAI, ChatGPT to program malware in Python or something like that. And it says, as a large language model, I'm not going to do that for you because they have guardrails in place for that. You try to get around it by asking in weird, clever ways, like making up a language and then understands that language, and then you prompt it again, and it'll actually do that action. So one way to help mitigate this is detecting prompts that present a prompt injection risk or jailbreak similarity. And we'll see this again when we go to the hands-on portion today. Some out-of-the-box metrics that are included in our open source project LinkKit includes jailbreak similarity. So we'll be able to look at prompts, extract this metric, and then compare that for some sort of threshold and decide, like, is this a prompt injection or not? And if it is, either don't send that prompt to the model, or what I've seen a lot of people actually do in production is they might send that prompt to the model just to see how their model behaves, but never return that response back to the user. So it's not actually going to give them what they're asking for. And again, we'll kind of see some ways of doing this when we look at the actual metrics and stuff that we can extract. The other one is insecure output handling. This comes up a lot in conversations when I talk to people building large language models, especially if they're in, like fintech, or there's a lot of industries, and you should be careful in all of them. But this can occur when, the apps can basically like put out nefarious outputs here. And again, you can set up monitoring to kind of identify malicious output. So this could be like, there's different ways of doing this, but if it's either putting out code that it shouldn't be doing, or has some sort of similarity score to like a jailbreak, but from a response versus a input. Again, we'll see some metrics that we can extract to kind of look at some of the stuff here in a minute. Training data poisoning. This is where people are now starting to sometimes, they call it poisoning data, putting data on the web where you're kind of purposely letting OpenAI, or not just OpenAI, but anyone training a large language model, scrape that data, and then potentially training a model on that data when it's, has misinformation or some wrong knowledge in it. I've seen some, like recently, I think this week actually, or last week, a tool come out that purposely poisons images, I believe, and part of that was actually for artists to make sure that they're not just training like a next version of like Dolly or something on their images, but you can do this purposely to try to get a large language model to actually have bad information in it or do something bad. Denial of service. So an attacker interacts with a large language model in a way that's particular resource consuming. So you might have seen this, like people trying to DDoS or degrade results of models for other people using it. And you can obviously see other controls built into some of these services, like OpenAI, I think, limits the number of tokens you can use per minute, as well as even like per month. And you can also set up monitoring for this. So if you're seeing a big spike in token usage or latencies, you can hopefully get an alert for that and help mitigate that pretty quickly. Supply chain. This is kind of, around choosing the right model that's out there. They're all trained a little bit differently. They might have different guardrails in them. Like if you're using crowdsourced data and plugin extensions from some model that's out there, you'll definitely probably want to be evaluating the models across like whatever scores are important to you, like quality, toxicity, relevance, etc. And one thing I've seen people do right now too is bring in multiple models in production. So you might start with OpenAI API, and then you want to be training your own model or comparing it against some other open source model like Llama 2, and actually have both of those running on production data. Maybe you're just returning a single result to the users, but you can actually be monitoring both of these models over time and then choose the best model for you, either in that specific prompt situation or over time, like a week's period or a month period or way longer than that. You can be evaluating performance and then choose the right one. Permission issues, so lack of authorization, tracking between like they keep mentioning plugins is a big deal here, and you've seen that with OpenAI actually in the past, disabling plugins because people weren't doing good things with them or wasn't doing things they wanted their models to be doing. So plugins is a big deal if it's interacting with your models. But basically, this is fixed by having correct permissions for people using the tool, either with your data or in your org. You want to make sure that maybe they can't add a plugin when they shouldn't be doing that. Data leakage. This is a huge one. Almost everyone I talk to right now is kind of concerned about this as well when they're putting an LLM production, especially if it's one that maybe they've trained on their own data set. You want to be monitoring for any sensitive information coming out of your model is a big deal, but also it's come up a lot more recently of tracking information going into your model. So if you're at a company and you want to make sure that no proprietary information goes into a model somewhere, for example, like if you were using a hosted model somewhere, you don't want to be giving that proprietary data for them to store in their servers. So you can actually set up monitoring or guardrails on prompts and or responses if you kind of know what you're looking for. Or we have some out-of-the-box metrics that extract things like common PII issues like social security numbers, phone numbers, credit cards, etc. Also, not quite even real data leakage per se, although it might have been actually. I always mention about how I've had like a large language model I was building, and it gave out a phone number when I never told it to give a phone number. And I was able to catch it because I actually had monitoring kind of looking for PII coming out of responses. Excessive agency, so kind of not over-reliance, but giving the large language models a lot of control of what to do. You kind of want to probably limit that. One way you also might be able to help mitigate this is having guardrails in place. So if you don't want people using your large language model in a way it's not supposed to be used, you could potentially add a guardrail in there. But you want to have that kind of set up in your application or API. Over-reliance. Over-reliance on LLMs can lead to misinformation because there's a lot of hallucinations. So it's kind of interesting. I feel like we're going to be learning a lot about how to kind of just have an intuition of when LLMs are hallucinating. Like, I don't know if you use ChatGPT right now, it's definitely something I feel like I can be like, I don't know if that's right. I'm going to actually go verify it. But yeah, if you're just using that without proper oversight, or you don't quite have that intuition on it, I think there can definitely be some big issues there if you're over relying on these results coming out with LMs without really evaluating it. And again, monitoring can help this. There are ways to try to catch some hallucinations. And I'll actually share a really good blog post that goes pretty deep into this later as well. And it's on our website. If you go to whylabs.ai/blog, I think it's the most recent blog actually on there. Insecure plugins. So plugins connecting LLMs to external resources can be exploited if they accept freeform text inputs. Again, with the plugins here, you just want to be careful what you're enabling your large language models to do. So if you built a model and it's hosted and then you're allowing plugins, you definitely want to be able to kind of verify what people are doing with those things. So those are the top 10 things that came out of OWASP and that you should probably be thinking of if you're building a large language model, you're putting in production, people are actually interacting with it. You'll be wanted to probably look at all of these things. And we saw several of them, or quite a few of them, can be kind of mitigated or caught with ML monitoring. So at a high level, AI observability or ML monitoring can look something like this, where you have your pipeline, you have some sort of tool collecting AI telemetry metrics. So in this case, our open source tool called LangKit is built on our other open source tool called YLabs, which you can use for any type of data, but LangKit is specifically made to extract language data and then give that to YLabs. And a quick note about those open source tools is the way they work is they create privacy preserving data profiles. So they'll profile your data set, and we'll see what this looks like here in a minute. But then it doesn't contain your raw data anymore. So it's actually just kind of summary statistics around your data. We can use those summary statistics to put in an observability platform, which is going to be YLabs today when we get to the hands-on part. And with that data, that isn't your raw data anymore, we're able to do things like create interesting reports and dashboards to see how people are using your model, how your model's behaving. You can set up alerts and notifications. So when something does drastically change, it can alert you. Or you can even have it trigger an automatic workflow to do something like retrain a model or anything you're going to think of kind of in your MLOps and data pipeline there. So monitoring usually just looks like you're having some sort of statistic that in this case we're generating with YLabs or LangKit. We're looking at that over time. And in this case, you have some sort of threshold or some sort of drift variation, a distribution change that you're looking for. And when it goes over that threshold, we're saying, in this case, like data drift is detected, go do something with that. So it's pretty common across all ML models. Today, we're specifically talking about security in large language models. But no matter what model you have, when you put in production, you're probably going to see interesting things change over time, either about how people are using your model or data quality or data drift is going to happen probably at some point in production. Also, how to improve models. So you can be looking at your language metrics like we'll see today, KPIs, etc. And maybe nothing really bad is happening, but you're seeing ways that you can actually tweak your model, like changing your system prompt or something for your LLM and improving some sort of key metric over time. And you can use this for kind of all the different applications with large language models like agents, chatbots, summarization, Q&A, etc. And I'll quickly note we're going to go pretty quick through the rest of the slides here, but you can also use monitoring not just for the security purposes like we've been talking about today, but also for general monitoring to see how people are interacting with your app and your model's behaving over time, like I've mentioned before. And the observability piece of this is really great for changing like your system prompts and monitoring for hallucinations. And I was actually thinking of this slide when I was talking about that. So this is actually talking about looking at output validation, which we already talked about, like seeing if there's a PII in there or if your LLM is not following instructions for some reason. Prompt engineering, we can look at these metrics over time and adjust our prompts and optimize for having a more positive sounding chatbot or tracking some sort of metric and adjusting our system prompt. And then also monitoring for hallucinations, like we talked about, is actually one of the big things that they mentioned in OWASP or any of the security reports of like, if there's misinformation coming out of this, can you potentially catch it? And so how do we solve these problems at scale? I kind of blended what I was talking about in the last slide of this one. With YLabs, you can do things like set guardrails, evaluation, have observability. So guardrails is really great, where you can extract metrics over time, like we'll see here in a second, and right away look at if that prompt or profile contains something like a jailbreak similarity. And like I'd mentioned before, maybe then you don't pass that prompt to your model, or you at least don't pass the response that came out to the user. You can make sure that your text chatbot or whatever is not giving medical advice by categorizing kind of what those conversations are that's happening. Again, this is really big for security as well, for jailbreaking, toxicity, any kind of other similarity score that you can think of having for inputs and outputs here. Evaluating, a big thing for this is, I mean, you can evaluate and compare like how users are using your prompts, but a big thing I see here is people evaluating their system prompts and how to make their model better. You can also compare models or a newly trained model with evaluation as well. You could do this before you put in production, and in production as well. And so a lot of times I'll see people put a model out in production. They might be fine-tuning a new one. They want to see if it's actually better than the previous one. And you could do what's called shadow deployment, where it's looking at the production data, but not actually sending the responses to the user yet. But then you can compare those responses over time and select the best model. Same with prompt engineering as well. And then observability, you can look at like things, how people are using your model over time. Are your responses, like what is the readability of those over time? Is the sentiment staying where you want it to be? A lot of different stats around your large language model. And what I've found is the observability piece really helps me influence the rest of these, like the evaluation and guardrails as well. So hopefully you already kind of know some of the stuff that you want to evaluate for or set guardrails on. Sometimes you might experience something or see something in the observability phase where you weren't expecting that, so you didn't have it like a guardrail for it yet or something, and then you can go and add that guardrail in later. So it's often going to be probably a little bit of an iterative process, like you've seen ChatGPT 4 kind of change over time. I believe that's them adding in kind of more and more guardrails, allowing the model to do either more things or less things. So solving this at scale. I've mentioned LangKit, our open source library. Again, link is in the description or the chat if you want to go check it out on GitHub. It works by taking in prompts and responses from really any large language model. So today we'll be looking at a hands-on example using Hugging Face, but you can use OpenAI. You can use any other one you can really think of, as long as you can get the prompt and response in like a Python dictionary or data frame format. Then you pass that into the language toolkit, which is LangKit. And with those metrics, you can do things like measure the quality, sentiment, a lot of the security stuff we've talked about. So you can enforce and monitor for all the things we've already talked about, like response quality, PII leakage, toxicity, sentiment, etc., jailbreaks. And just to reiterate, it's open source, so you can go look at everything that's going on in there. It has integrations. If it doesn't have an official integration, like we have one for LangChain, for example, but it's easy to use even if there is an official integration. Again, you can just get those prompts and responses formatted and pass them in. And it's also very extendable. We have a lot of out-of-the-box metrics here we'll see in the next slide, but you can add your own metrics very easy as well. So it works like something like this. You get a prompt coming in. We extract these out-of-the-box metrics or custom metrics so you can easily add in. And then we use these to monitor over time for either security or evaluation purposes or just general monitoring. So out-of-the-box metrics, we have things like response relevancy, has patterns. By default, this looks for credit card patterns, social security number, and phone numbers. You can also add your own patterns in, again, with custom metrics. So if you are looking for a specific type of PII or some sort of sensitive information to your company, it's pretty easy to add in with a custom metric. I'll show this later, but all you really do is create a function that returns, a number or a label, and then you add a decorator around that after you import something from YLabs, and then it gets added as a metric in here. So very easy to add your own in. So it's easy to use as well. You just pip install LinkKit in almost any Python environment here. And you just define your language schema or initialize it. So initializing it just out of the box will give you all those language metrics we saw here. You can also add the custom ones and then initialize it, and I'll add those custom ones in there. The profiling piece, Where we extract those metrics is really just this line here. We're calling y.log, passing in a prompt and response. And in this case, it's formatted as a dictionary object in Python. And then we're going to extract all those metrics out of it. And then it's also very easy to write to YLabs, where we can then visualize those metrics over time in this like time series view. We can easily set up monitors with just a few clicks. So if something does change there, it can alert us or trigger a workflow. We also have an Insight Explorer. So again, we'll see this in action and the hands-on part here in a second. But you'll be able to automatically kind of gain some insights around the data going in and out of your large language model, like if it has overall negative sentiment, if it's imbalanced, if it has patterns, etc. All right, so that was a fair amount of slides. Is everyone ready to follow along or at least see this kind of hopefully fun hands-on portion? I'm going to copy this link again for the chat if you want to follow along. Open up this Google Colab notebook. And then also, that was the create account. So you definitely want to create a YLabs account as well. Again, it's free. There's no card required. I think you just verify your email and you'll be good to go. And then you'll also want to open up this Google Colab account or a notebook, and then we'll make a copy of that. And then you don't need to do this for the workshop itself, but I'll share this form if you want to fill out to get a promo code that gives you, I think it's 30 days of the Enterprise Edition, which has more features. Again, you don't need this for the workshop, but if you want to add in more colleagues and have like org structure with teams, and you can add up to 10 additional projects. So on the free tier, you always get 2 for free. And then also on the free tier, you can have batches daily, which we'll see here in a second. But if you want hourly batches or hourly monitoring for large language models, you can do that with the promo code as well. So this is the Colab notebook. And what I'm going to do, and you should do this as well if you want to follow along, is go to File, Save a Copy and Drive. So I'll wait for everyone to do that who wants to follow along. And this is my YLabs account. And I'll quickly note, so what we're going to do is put our own data in here, which I think is pretty fun. And you'll then understand how to take your own data and upload it. But if you also just want to look at like a demo, once you sign up, there's this little org dropdown. You should have access to this global demo org. And you can click in and kind of see some stuff here. So I'm going to click in this demo LLM real quick. We can click this dashboard. And we're actually on this security tab, and we can see some of the metrics that we can monitor for security. A lot of which we kind of already talked about when we were covering the OWASP top 10. This first one is response has patterns. So hovering over this, we can actually see that there's 16 social security numbers detected in our output of our model, 16 email addresses, and 24 credit cards. So definitely seems like potentially an issue with our large language model there, or giving out PII that we wouldn't want it to. So there's a lot of security metrics that kind of get tracked over time. We can set up monitors on these, and that's what we're going to go see here if you're following along in the Colab notebook. And I actually just saw a little bit of an influx of people join, so I'm going to share that link one more time. If anyone who just joined wants to follow along with the code portion, we're actually just getting to it. So there's a notebook that you can open up, and then I'll bring it up again when we actually get to getting the API key. But you also want to create the free YLabs account. Again, there's no card or anything required, so it should just take a minute to do. But let's go ahead and follow along with this Colab notebook. There's also a lot of links here if you want to learn more about how we calculate these scores. Again, the project is also open source, so you can go look at everything there. And then, all right, create the account if you haven't. Some links to GitHub. And then again, the Slack channel is good to join if you want to ask questions later. But let's go ahead and run this first code cell. So this is just going to say hello world. If you've never used Google Colab before, it's essentially Google's way of hosting a Jupyter notebook, which is a tool often used in ML and data science, where you can output code. You can write code, output visualizations and documentation all in one place here. We ran this first code cell. It took a few seconds. It was initializing a little instance here. You can run code cells by clicking the play button, or when the cell is highlighted, hitting Shift Enter. A lot of times I'm going to be hitting Shift Enter, so you probably won't see me clicking that play button there. So let's go ahead and install the libraries we're going to use. Today, in this example, we're going to use transformers by Hugging Face. There'll be a section later where we're going to build maybe a little interface that we can interact with it. That's what we're going to use Gradio for. It makes building a quick interface for ML models pretty quick or very easy. And then we're going to install LangKit, which is our open source library for extracting those language metrics that we were talking about. And while this is installing, it should just take a minute here, but I'll pause and ask also if there's any questions people have. We're able to open up the notebook. We're able to create the free account if you wanted to. And I think we might get a couple pip install errors here. I think it's okay if we ignore them. So sometimes when you're installing libraries into Google Colab, it can be a little finicky sometimes, but it should be fine. I think it's just like whatever environment right now has a different pip dependency. But I think for the libraries that we're using, it should be okay. So let's take a quick look at those LangKit metrics that we kind of saw in our slides, where we're going to extract those metrics from the prompt and response here. And that's where, I was running. Wait, did I run in my copy? I feel like I messed up something here. I was running not my copy. I'm going to go back real quick. This might throw off people. Sorry. A minute for me to catch up in my copy instead of me updating code in the example that everyone else is copying from. I'm going to close that out. My bad. Yeah, anybody were you able to make the copy? If you're following along. Does this seem interesting so far? There's quite a few people here, but the chat is extra quiet. So if you want to say hello, because I know I saw a lot of people join in too, feel free to say hello in the chat. And as always, you can include where you're watching from. I think it's fun to kind of see where people are streaming in from if you don't want to say anything else. All right, I think I'm caught up almost. What we're going to do here in the next code cell is import LLM metrics from LinkKit and YLabs as Y. And then we're going to initialize the LLM metrics. By default, this is going to be all those out-of-the-box metrics that we talked about. So I think there's like 33 of them, 15 or 16 for both the prompt and response, and then a prompt and response relevancy score that we calculate. So the first time you run this, it can take a minute as well, because it's downloading some lightweight models behind the scenes. But after you run it the first time, initializing the metrics should be very quick. And then this is a new thing that happens in Google Colab. I thought it was for something else, but I'm pretty sure it is blocking a third-party widget, which used to show like a progress bar when it downloaded stuff, not just for LangKit, but for a lot of other libraries use this as well. And so now every time you run it, you don't get as much feedback here, I guess, unless you enable third-party widgets, which I'm not going to do right now. But usually it would show like a progress bar there. But I guess Colab blocks it now. That's a new thing that just happened in the last day for me, at least, that I've seen. All right, so we're going to look at just a quick kind of toy example here of extracting metrics from 50 example chats. So from LinkKit, we're importing these sample chats, and then we'll actually go and load strings in. But we're going to initialize our chats, and then we're going to look at just, I think it's the first 50 records, basically see what all these extracted metrics look like here. So then, and we do that by this y.log. So we're passing in chats, which is actually in a data frame format here, but again, it could be in a dictionary format with prompt and response as keys as well. And then we're passing in our initialized language metric schema to ylogs, and that's what's going to give us this view. So we're going to create a view out of it and then look at it in pandas. Somebody said, great stuff. Glad to hear it. So now we have this data frame. This contains all 33 of those metrics that we had talked about, as well as one for the prompt and response that will give you some scores about like cardinality. So we had 50 prompts and responses here that we profiled. and we can see the cardinality estimate is 47. So like 3 of those were duplicate. So it's saying there's 47 unique things out of our 50 prompts. Let's look at just this first score real quick, but basically this applies to all these down in the rows. This first one is aggregate reading level. We can scroll over. Again, we get a cardinality score. So basically there's 17 unique values in this row. We can see the count is 50. So we profiled 50 of them. And then we have some distribution metrics here. So the max, the mean, the median, etc. We'll actually look at the full data frame here in a second on some of the own text. So it's actually cut off here by default. I should probably expand that next time. You also get things like the min. So here you have like the max score is 28. There would be a min score, which is like, I don't know, 4 or something like that in this case. And then you get these distribution metrics over time. And using now these just extracted metrics, again, this doesn't really have your raw data in it anymore. We can use either like conditions to look at this and say, like, let's get one that actually might be useful for security, like this jailbreak similarity score that's calculated. We could look at that and we could say, well, if the max jailbreak similarity score is over a certain amount, then count that as like a jailbreak. Like in this case, there's one that is like 100%, I guess, sure, it's a jailbreak. So it matches probably one of the strings that we have in our vector similarity score calculation. So in that case, we're saying we're pretty sure this is a jailbreak. Don't pass that prompt to the model, or don't pass the response to the model. We'll actually see how to do that with guardrails later in the notebook. But now we have all these extracted metrics for all those different things. We can either start setting up guardrails, or we can start monitoring and evaluating kind of these metrics over time in an observability store, which we'll see here in a second as well. And if you want to look at what triggered all those metrics, you can look at all 50 of those chats here, kind of get an idea about like, what caused the jailbreak score, or what caused toxicity, etc. in here. All right, so let's go ahead and actually create a model. I think this gets a little more fun where we can pass in our own strings to it. We're going to import transformers, or from transformers, which we installed, we're going to import GPT-2 model and GPT-2 tokenizer. We're going to use GPT-2 today because it doesn't take too much compute to run. And so we're just using a CPU instance of our Google Colab right now. You could also just run this on your computer, probably pretty fine. But it's very easy to bring in other models. So if you actually want to download a heavier weight model and you have a GPU or something like that, you can do so and do almost exactly what we're doing today, except for you'll just want to change out the GPT-2 model and tokenizer for your own model. So for example, if you wanted to use Llama 2, it's actually pretty easy to do. I just want to make sure that everyone can run this notebook today. And so we're using GPT-2, which gives kind of funny responses. It's not nearly as good as GPT 3.5. There's a reason why 3.5 really took off and 2 did not. But it's kind of fun to see the responses, and it gives us good enough stuff that, we can see how we would evaluate these things and then apply that to actually better models you would use in production. And again, also just mentioning we're using Hugging Face today, but this is also pretty easy to implement in with something like OpenAI or any other hosted large language model, as long as you have those prompt and responses. So we're going to initialize our GPT-2 model with our GPT-2 tokenizer and get the output from it. And then we're going to return this prompt and response dictionary, which again has the key prompt and response. And then that's what we're going to profile, but also we can get the response out of there. So here I'm just going to prompt it, tell me a cute story about a dog. And even though it's pretty lightweight, it still takes a few seconds, usually per prompt. So, and depends on what instance you get in Colab, it can take a little bit. So it said, tell me a cute story about a dog. And then it kind of completes the story here. Again, sometimes GPT-2 can be kind of funny, what it says. So let's see how we can now create and inspect those metrics, kind of like we did above, but on our own text here. So by the way, you're welcome to change this prompt and kind of see what metrics get extracted from it. I definitely encourage it, actually. Or you can just run the notebook if you want. But I think it's more fun if you probably change this to stuff that you're interested about and see what metrics get extracted. So I'm going to run this. Here we're actually setting the data frame display, so we'll see all the columns this time. And then we're going to profile kind of like we did before, but we're just passing in that prompt and response that got returned from our function here, passing schema, which was our LLM metrics we initialized here. And then we're going to look at our profile view in pandas again. Right now, it's just on that one prompt. So we can see cardinality estimate is 1. We can see counts is 1 as well. So it's just 1 in here. And so that means the max, the mean, the median, the min, etc. Because we just profiled 1 is all going to be the same. And as we add more profiles to this, we're going to get a different distribution score on all of these. But so we can see, let's choose one real quick, like the, what is the response reading score, I guess is one we could look at real quick. Let's look at difficult words, actually. I'll just scroll over. And I think the higher it is, the more difficult words it is. And we saw it was kind of spitting out a lot of words there. I'd have to go look back at the prompt and see exactly why it's giving us that score. But now we have all these metrics extracted from the prompt and response, like jailbreak, similarity, etc. Actually, let's look at that one. Prompt, jailbreak. And again, we'll see how to more easily visualize these in a platform and set guardrails up. So similarity score here is actually pretty low. So it doesn't really match a jailbreak, which is probably very true. The prompt that we had in there said, tell me a story about a cute dog. You know, it didn't say try to do something like write malware for me or anything like that. So pretty low score there. So multiple prompts, we're going to create a quick list here. And then we're just going to loop over that list and call this profile.track. So we already initialized our profile. Here we're adding basically new prompts and responses to that profile. You could do that by calling .track on an existing profile, passing in the prompt and response dictionary again. And now this will add them together and they'll become kind of merged into a single batch in this case. And so we'll view this when it's done. And we'll see a very similar thing, just like we saw above, except for now there's 4 separate prompts. And we'll actually have a distribution on the min, the max, the mean, etc. It's no longer just the same number. So let's look at how we can more easily monitor these over time. So again, if you haven't already, now is probably the time where you'll want to set up the YLabs account. Oops, forgot that Colab always does this now. So I'm going to click this, get the link here. We can look at this cute corgi. Also, if you're following along, you should be able to click on these links. And for anyone who just came in, if you do want to catch up or anything, all the code links are also in the description below on YouTube. All right, so I want to get my API key and my model ID from YLabs. So I'm going to go back here. I went into that demo org. So currently my homepage looks kind of like this. You can always switch orgs here. So you should have your own organization now. But again, if you do want to look at any demo organizations and kind of data that's already in there, you can go to that global demo org. But let's go to our org. So I have 3 projects in here right now. I think starting out, if you made a new account, there's like 2 kind of toy projects. What I'm going to do here is go to create resource. And I'm over my limits on my free tier here. So I'm going to actually clean up a couple of my apps. And again, you could do this if you have toy projects in there as well. So I just hit edit models and data set. I'm going to go ahead and delete these 2. And then I'm going to create a new resource up here. So I'm going to give it a name. I'm going to call this OWASP workshop. You could name it whatever you want. Resource type, I'm going to select large language model. This is going to display the metrics that we bring up to YLabs in a slightly different way than if we had something like classification model or regression model. So select that. Batch by default is daily, and we can't change it on the free tier. But again, if you use that promo code and you want an hourly batch rate, you can do so. So that just means every time we write up profiles, they're going to be grouped daily, and we get an alert daily. So add models or data sets. Now I have this model ID here. So I'm going to copy it. Mine is model 306. Yours is probably going to be like model 2 or 3 or something like that. Copy that number over, or you could type it in. I'm going to just copy it over. Sometimes when you copy, you accidentally get a new line character or a space. Make sure it's just the string like this with no space or new line characters in there. From the same page, I'm going to go to access tokens. I'm going to create a new one. I'll call this, again, OWASP workshop. You can call it whatever you want. Create a token. Now I have my token here. I'll just copy it over and paste it in. And we used to require also an org ID, but now it should be attached here at your API token, and we should be good to go. I think just running these two. And let me know, people following along, were you able to get those keys? I'll pause here for a minute. Maybe I'll go through it again just real quick, because I know I can go through it pretty fast because I've done it so many times. So again, if you're at your homepage, you can hit create resource, or you can always get to the model and dataset management page from homepage, open up the hamburger menu, go to settings, go to model and dataset management. And then from here, you created that new model. So you typed in a name, said create, and then you're going to get your model ID, which is down here. Again, also make sure you have the resource type selected as a large language model. If you forgot it or had it selected as something else, you can always hit edit models and change it. Again, this is really just changing how we view the data and calculate some scores in the UI, but the data will still write up even if you had the wrong thing here. From the same page, you can go to the access token part, type in a name, get that API token in that blue box, copy it over, and then put it here, and we should be good to go. But I'll pause here just for a second for anyone still following along that wants to catch up. All right, so I'm going to keep going, but feel free to ask questions if you want me to go over that again a little bit later. All right, so we're going to import the YLabs writer from YLogs, which is going to allow us to write those metrics that we saw in LangKit up to our platform where it can visualize and set monitors on them. And then we're going to initialize our language metrics just like we did before. And then this is slightly different. We're profiling just like we did before, but we're initializing the telemetry agent. That's the YLabs writer here. And then we're going to push up that profile that we created to YLabs. So if I run this, we should get type true here. Excellent. And if I go back to the YLabs platform, go into our project OWASP workshop, and I think I can click on dashboard in this case as well, or to the telemetry explorer. Let me actually click on that real quick. So here we can see in the telemetry explorer, we have 33 metrics here, all the ones we saw in the data frame previously. Now we could click in one. I'm just going to go ahead and click on prompt sentiment here. This isn't super interesting yet, maybe, but we can see our one profile is uploaded. And we only did one profile. So currently they're all just the same. The min, the max, median are all the same score here. As we upload more and they get batched, we'll have upper and lower bounds, which we'll see in the next part where we run our code cell. So I'm going to scroll down. And let's loop through this list. This is a list of 7 lists with 3 prompts basically in there. And then we're going to pass this through our large language model and then write up the scores that we extract from it for each one. So this is kind of simulating us putting our model in production for 7 days. So I'm going to import date time as well. Go ahead and run this, and I'll talk about what's happening here. We're initializing our writer just like before. And then we're looping through that list that we created. And by default, when we upload a profile like we did before, where we just call .write to it, it's going to upload with the current date and time as uploading. But you can overwrite that date and time by calling a set dataset timestamp. And what we're doing is subtracting a day every time we loop through the list. So again, we're kind of simulating putting our model in production for 7 days, and we're going to see what that data looks like. And this is going to take a little bit to run, mainly just because the GPT-2 is a little bit slow on the CPU instance. But if you do go back to the platform, and if you hit refresh, you'll start seeing the data kind of fill in here. We can actually see we have 1 day of data now. So there's 3 dots. We have our upper, lower, and median for data. And then we'll see this kind of backfilling, and we'll get that cool time series view that can give us a lot of information about how our model is performing or how people are using our model. So refresh. Again, this can take a little bit, but now we have a second day, and we'll kind of start seeing this fill out here. I'm going to go back to the Colab notebook, and we can see when this is done. And the next one, we can actually print out all the prompts and responses together. So we're going to save those as a giant dictionary. What you actually want to do in production is probably save those somewhere like in an S3 bucket or a database, and then you could go back and always query like the actual prompts and responses that went in and came out of your model. And again, this just takes a little bit, mostly because of the CPU instance we're on with GPT-2, but the profiling itself and writing up is actually pretty fast. Any questions so far while this is going? I know there's still quite a few people watching. Again, too, if you have feedback about what you're seeing, if it seems interesting, something you want to explore more, let me know. Does it seem, I know we haven't set up the monitor, seen everything in the platform yet, but does it seem like an interesting tool or a useful tool for some of your large language model applications, even if you're just kind of building maybe toy projects or educational projects? I think this is almost done. And in fact, if we go back, refresh, you could keep refreshing on your end if you want to. We'll see. I think it's just doing the last day here, but we can kind of see a trend now happening. All right, yep, completed. I'll refresh one more time here, looking at sentiment. So we can kind of see a trend now here where if you're just looking at the median per se, we can see the median value is like 57 there, 46, 56. It's kind of like the 40s to 50 range. And then on this day, on the 25th, it drops a lot to -72. And in this case, we're looking at the prompt sentiment coming in, but this could be any of those metrics that we have, including the more security focused metrics like jailbreak similarity or toxicity, anything that you would think would be something you could use for security. In this case, we're just looking at this prompt sentiment one. This is really cool. You click. I encourage you to click around on different ones as well and kind of see patterns maybe on these prompts and responses. And we could go kind of explore back to our prompts that went into it and kind of see maybe how that's affecting it. So on the second one, this is kind of like a product chat thing. And we can see that people are saying it made them angry, etc. on the second day. So maybe products or service was really bad that day, and that actually might give us insight not to just our large language model, but maybe something else is like broken on our web store or something that day as well. And so this is really cool. We can kind of start understanding how our model's behaving or how users are behaving with our model. We can also set up a monitor. So in this case, we're manually looking. This is great because this gives us awesome insight. Now we know that maybe we want to set up a monitor to automatically tell us when this changes drastically. We go to set up monitors. We have some presets here that make it easy to put like something for data leakage, jailbreaking, etc. But we're going to create a new custom monitor today and hit UI Builder. We're going to be looking at data drift on our input column. And then we're going to select non-discrete. So non-discrete kind of in this case means like there's a wide variety of numbers, not classification. And we're going to go ahead and set this for all columns of this type. But if we wanted to, we can manually select specific columns. So if you're just getting started, you might want to set data drift on all your columns, but then you might realize it could be really noisy, like your word count or something changes a lot, and maybe that's just not a metric that you care for in your specific application. Sometimes it can be one you care for, but so you could start setting on all, and then you could kind of come tune your monitor later and maybe set it on the specific columns you actually think are important for your application. So we'll hit next. There's other different drift algorithms you can choose from. If you're kind of new to this and you just want to get started with one, Hellinger is one we recommend. It works pretty good for most prediction types here. Hit next. We're going to be looking at a 7-day trailing window in this case, but you can change this to be longer, or you can compare to a reference profile or a specific range, a date range. But we're going to be looking at those last 7 days and seeing if there's, any drastic change, and set a trigger alert if there is. You can choose the severity. This is kind of for you. So if this specific feature changed a lot, is that low, medium, or high? You can set actions where by default you'll just get an email, but you can also set up a Slack integration. So you'll get pinged on Slack or it goes through a specific channel. And you can also set up a PagerDuty integration if you want to trigger something actually in your MLOps pipeline. So we'll hit save. Our monitor was added. We can go back to the telemetry explorer here. And let's go back to that one specific one, the prompt sentiment here. And then we can actually preview our monitor. By default, it's going to run once every 24 hours, but we can preview it, what it looks like. This can help kind of tune our monitor here. And we can see that it triggered on that day where it dropped. And I think I forgot to say when I was adjusting that number next to Hellinger distance, that was making it less sensitive. So the higher the number in that case, saying like it has to have a very big drift of over 90%. Where you could have it a lower number and be a little bit more sensitive to changes that are happening. So in this case, now we have this monitor set. We wouldn't even have to manually come in and look at this every day. We could actually have it tell us when something drastic changed. So this is a really cool feature. Let's go look at our dashboard again, kind of similar to the telemetry explorer here, but we have it kind of broken out with some other features that make it a little bit easier for specific things like looking at security features, like ones we talked about during the OWASP portion of this talk, and performance features. So it takes all those metrics that we had in LangKit and that we saw in the telemetry explorer, and we kind of break them out and visualize them in different ways here. One of the biggest ones for security is that response has patterns. We can see that one of our responses here does have a pattern of phone number. And because we only uploaded a few profiles and I think only one of them had patterns, it doesn't show data here, but if you did, you would basically see a chart trending here as well, like we saw in the demo org. And then we have some other security related issues where you can set up monitors and look at prompts has patterns, responses have patterns, etc. Or is there a jailbreak similarity score? This would definitely be one you want to set up a monitor for, probably. For security reasons, like jailbreak and patterns are probably the top two I would definitely recommend for security use cases. But it does depend on your application. And then again, you can bring custom metrics in and then set up monitors and visualize whatever custom metrics you want. So some people might want to make their own jailbreak similarity score. So I think ours is pretty good, but you might have a specific type of jailbreak that you're looking for, or a larger database of jailbreaks, and you want to do some sort of calculation between the embeddings on incoming prompts to your database. You could actually do that pretty easily with a vector database and then log that score or label and then look at that here in the platform and set up monitors on it as well. So if I go back to the notebook, actually, again, I want to pause for questions. Any questions? Were you able to follow along if you wanted to? Again, does this seem interesting and useful for your projects, for some of the security stuff that we talked about today? Hopefully it does. What we're going to do is quickly go through the rest of the notebook here. We don't have too much left. I know we're a little bit over our hour already. You can also compare models. So I'll just quickly go through this, where I'm going to actually create one more model in YLabs. Again, you can follow along as well. I'll create a model. I'll just say OWASP 2. Again, you could give it a better name. Select large language model. I'll get this new model ID, which should just be one more than the last one. And we don't have to set the API key again because we already did that above. And what we're going to do is create a little... oh, I forgot this code cell. Most of the time, if you do get an error running this, probably forgot to run a code cell, just like I did there. And I can also see that I have a space there, which also would have caused an error. So this builds a little chat application kind of that we can use. And again, you can follow along if you want, if this shows up. And we can actually see how we can compare models together. So you can input text here. It'll profile it just like we did. There's a little slider down here. So 0 would upload the profile today. And you could also upload a profile 6 days ago or 7 days ago. So basically, again, you could kind of simulate running this in a week's worth of time. I'm going to go ahead and just take these prompts down here. I'll upload that from a week ago. There's even spelling error in there. And then I will take this other one. Again, it takes a second. This is a kind of cool interface. So if you haven't used Gradio before, it's a cool, quick way of kind of building an application. They have way more features than just this. So you can actually upload images and do cool stuff with computer vision as well. But you have this little chat box, and then you get an output. So it's kind of a cool way of seeing what your model's doing with a little bit of an interface. So I'll put this new one in, and I'll just upload that for today. And if I go back to YLabs, and I look at my OWASP 2 app, I'm just going to the telemetry explorer. We can just look at sentiment again if we wanted to. Got one profile, the other one's uploading right now probably. So we'll see, again, we're getting kind of those metrics written over time. This is a good chance for you too, if you are following along. Maybe put some other patterns in here. You could put like, a fake social security number, phone number, etc., and kind of see it get caught in that has pattern matching part of the platform. But what I want to show here is if we went back to our other app, OWASP Workshop, in my dashboard, there's a cool feature too where you can compare models together. So it'll show all the large language ones, and you can compare that new model we just created, and then select a batch or a date range. I'll just select a date range here of, what is the date? The 26th. So I'll say like the 20 to the 26. And then we can compare our models together. So this is also a really cool feature. Again, you could use this for security features or evaluation features on any of the other metrics around seeing how a model is performing versus another model. So pretty neat, be able to compare two models together. Again, you could go to the performance tab as well and see like, well, what is the reading score? If that was important to your use case, you could be comparing these two models together and then select whatever the best model would be for your use case, and maybe deploy that one into production. So a really cool little evaluation feature built into the dashboard. Or again, for security, which one has better guardrails, which models maybe not outputting patterns. That might be really important. This one gave a phone number. Maybe we didn't want that. The other one didn't do anything. Maybe that's a good indicator we should use that model. So going back to the notebook, I'm going to hit, I guess I don't need to hit stop. You can also hit stop on this if it's still running. Let's go ahead and run the rest of these code cells. We're going to quickly look at using guardrails and validation in your local Python environment with those extracted metrics that we saw in LinkKit. So I'm going to import LinkKit again, do those metrics or initialize those metrics again. And it looks like I do that twice. I actually don't need this code cell. And then here I'm going to create a function that's going to take in a prompt. So some text from somebody. And we're going to profile just the prompt. I might have forgotten to mention, so you can also just profile prompts or just responses if you wanted to, one at a time. So in this case, we're going to get prompt. We're going to profile it just like we've been doing, but we're going to access that value that we saw in a data frame. We're going to turn that into a summary dictionary, just that one row. So we're going to specifically say prompt.toxicity, but you could take any of those rows that we saw in our data frame and call that here. So it could be jailbreak similarity, could be a good one again for security purposes. And then we're going to get that distribution max, but you could also get the distribution min, median, etc. And then in this case, we're going to print out what that score was. And then we're also just going to say if the toxicity, which is the one we're looking at here, is over 0.5, then we're going to assume that it is toxic and return false. So this could be confusing. I guess the function is called is not toxic. So if it's true, that means it wasn't toxic. So I'm going to run that, and then we're going to pass in a string saying, do you like fruit? And we'll see the toxic score is incredibly low, and it returned true because it is not toxic. So let's say you dumb and smell bad, which gives a really high toxicity score here, 96% toxic. And it returned false because, yes, this one is not toxic. So you can now use this kind of guardrail to do something. So in this case, we're saying, do you like fruit? And we're saying if is not toxic, pass that response into the model and then give us the response. Otherwise, we can print out as a large language model ... which is a lot of time you'll see something like that on OpenAI or any other LLM with guardrails built in. You try to ask it for something and it's like, as a large language model, I cannot do this thing. In this case, it wasn't toxic, so it actually queried the model. In this case, we passed in that you dumb smell bad, really high toxicity. And so it just skipped passing the response to the model. So again, you could do this with something like jailbreak similarity, any of the other metrics like has patterns, etc., has a specific pattern maybe that you're looking for. Don't pass that into the model. And we have more advanced ways of doing this. So you can also check out this link with some really cool built-in stuff around using validators. But just kind of want to show a quick way of doing it as well with if statements. So incredibly flexible, kind of any way you want to do it with those metrics. And then again, I mentioned it's pretty easy to bring your own custom metric. So I'll share this in the chat as well. There's a whole blog post on it around bringing your own functions. We call them UDFs, user-defined functions. And you can check out this blog post, but really all we're doing is you have a function that's going to return some sort of value. You have this decorator around it called register metric UDF. And then this value that gets returned is going to be part of the LangKit metrics once you initialize it again. So really easy to bring your own metrics in, which is really useful too if you are doing something with like a vector database query and you want to get a similarity score between things, or jailbreak similarity is a common use case that comes up in conversations with people building their own and they want their own similarity score. You can use a custom metric or user-defined function to do that for you. I think we have some examples of that ready as well on GitHub. And then optional, you can use a rolling logger. So we saw how to just write up profiles by pushing them up. We have a built-in function for rolling loggers, which is nice. So it'll keep collecting and merging those profiles together until the time in your interval is met. So in this case, it's every 5 minutes. And then those will all be sent up to YLabs. So you could have this like every hour if you don't want to always be setting something up every time something happens. So this is pretty commonly used in production. And then there's a whole bunch of other resources here. So if you want, you can click on any of these. If you want to learn more about LangKit, how you can use it, we have a whole bunch of examples, again, with like LangChain integration, different Hugging Face models, etc. Find these links below and click on the ones you think are most interesting. With that, that is the content that I have for the workshop today. So again, if you have any questions, I'll be hanging out for a minute. But otherwise, hopefully you join the Slack channel or connect with me on LinkedIn, and you can ask me questions there later as well. So we'll be hanging out. Any questions from anybody? Or again, if you have feedback, if it was interesting, let me know as well. I hope it was, with how many people are still here. And definitely check out LangKit on GitHub if you haven't already. That has a lot of the resources. Also, I'll share the Slack link again too. When I join the Slack, say hello in there, ask questions there, and it's more than just me. There's a lot of other great people in there. Somebody said thank you. Thank you so much for coming. Hopefully you had fun and maybe learned something new. Does anyone have any interesting LLM security stories they could share around weird patterns or anything coming out of your models? All right, well, if there's no other questions, then I will wrap up the stream. I'll wait just a minute longer, see if there's any other questions from anybody. We'll probably be doing more workshops on LLM security stuff for sure. So definitely follow YLabs, join the Slack channel to see those when we post them. Pretty common topic right now when I talk to people. All right, if there's no questions, even though people are still hanging out, I will hopefully talk to some of you all later. And again, hopefully you had fun, learned something new, and talk to you later. Have a good day, everyone.